Back guys, today we are back with another problem, and before I go and solve this problem, make sure you guys like, share and subscribe to this particular problem statement, particular channel. And today's problem is majority elements. So what majority elements is like? So you will be given a particular array. So I will explain. I have not written the problem statement. You can go check out in the link in the description to go to the problem statement. I've just cut it to the shortest possible way so that I can give and deliver a presentation of this problem statement in a very quick time period. So what we can see is that we are having certain elements. So there are total number of elements as 11. Okay, so we'll be total having, say for example, 11 elements. Okay, so what you can see, the elements present in this particular array are 2 1, there are 4 5s, then there are 5 6, means there are 6 times 5 6 times there are 5 times 6. Okay, and there are 4 times 5s and 2 and 1 is present. Now our task is to return those values whose frequency is greater than n by 3. So what is n by 3 over here? N is nothing but 11. So when I'm doing n by 3, what I am getting is 11 by 3, which gives me a 3 2 by 3. But you know that we will be using integer values and storing our length as length of the array as integer. We cannot take negative. So what we can say is we are going to round this off. So after rounding this off, we will get integer will automatically store the decimal position, which is 3. So what you can see is we are having 3, and 3 means the total frequency of that value should be greater than 3. So when we check the frequency of the values, 2 is repeated how many times? 1 time. 1 is repeated only 1. 5 is repeated 4 times and 6 is repeated 5 times. That means 5 and 6 are the only elements whose frequency 3 is greater than n by 3. What means? That means its frequency is greater than 3. Why is it greater than 3? Because 3 is coming. We are doing the calculation of n by 3 from here. So we will be getting the output as 5 and 6. So how we can solve this particular problem statement? So the particular problem statement, first I'm going to give you two methods. Okay, this is slightly a medium method and it is also doable method. Okay, so this is known as a Boyer-Morse voting algorithm. Okay, so this is Boyer-Morse voting algorithm. What you can clearly see is that we are going to return the candidates which has votes greater than n by 3. So it uses a process of candidate selection. It takes two candidates. So what is the process? I am going to explain the algorithm. We have to maintain two potential candidates. So there will be candidate 1, okay, and then there will be candidate 2, and each will have their own counter 0, counter 0. This counter value gets updated with the help of the algorithm. So what you can see that we have to maintain two counters. If it matches, then we have to increase the count. That means that, okay, the present counter is first candidate, say example is 5. Next value is also 5. That means the first candidate is now matching with that second candidate. So in that case, I'm going to increase the counter of that particular value. Okay, so that is how Boyer-Morse voting algorithm works. Previously, it was used to do for n by 2. So, but now we are going to modify it using an extended version and make it as n by 3. So the two steps are there. First is candidate selection and another is candidate validation. Okay, that whether anything is left or not. Okay, so this uses a time complexity of O of n and a space complexity of O of 1. Okay, so it gets done in efficient time and space complexity. Why this is the best, I will come later. Okay, now let us go with the second approach, which is many people love this approach. This is the HashMap approach. First, we have to store all the values in the HashMap. Okay, we have to extract the keys of the corresponding values, and if the key is greater than n by 3, we have to add it to the list. Okay, we have to add it to our list, or else we are going to add return of -1. It has a time complexity, what we know that it has HashMap has time complexity of O of n and space as O of k. So over here, what you can see is we are using O of k, but over here we are using O of 1. So obviously the first approach is a better approach. Although both has time complexity, if space complexity is not an issue, you can go with the Boyer-Morse algorithm or you can go with the HashMap approach. So let us discuss the HashMap approach. So you have the nums arrays. This is nothing but my nums array. What I'll be storing the values 2, 1, 5, 6. Now I'll be storing the frequencies. As you know, that's how the HashMap works. So 2 has a frequency 1, 1 has a frequency 1, then 5 means first the frequency will be 1, again it is repeated, then that means 2, again it is repeated, I'm cutting it and updating as 3, again it is repeated, so I'm updating as 4. Similarly, when I'm starting with 6, I'll be starting with the 1 value, then I'm going to 2, okay, then I'm going to 2 and 3 and 4 and 5. So that's how this frequency is updated. Now once the loop is and once the calculation is done, I'm going to take the value of the elements and whoever's frequency is greater than n by 3, I'm going to take it, or I'm going to put -1. That's how the entire algorithm works for the HashMap approach. It's a very simple process. Okay, so now we are going to discuss the coding part. So let's first discuss the HashMap approach. We have a function majority. We have a list as our return type. Okay, so we are going to return the list as return type. Now what you can see that we have this integer nums value. Okay, we are taking this nums value as well. We are taking a hash map. Okay, and now we have a hash map as well. After that, we are putting those values, and then we are extracting the key set. From there, if the thing matches, if the size of it matches greater than n by 3, we are going to add it, or else we are going to put -1, as I've already discussed. So this is the hash map approach. Now comes to the Boyer-Morse algorithm. Okay, so this is nothing. Don't be scared by looking at this algorithm. It's nothing. It's very simple algorithm only. So what you can see is we have a class. We have a class list integer. Find class solution. We have a return type as integer. So we are going to return this. First, we are going to check whether our list, whatever the list array list it is, we are going to check whether it is null. This is our base cases. Okay, base cases. If we found a null value or we found a 0, we are going to put -1 in that place. Now we are going to take two potential candidates, as I told you. Initially, the candidates are storing -1 as their position values, and count of these candidates are taken. Now n is nothing but the size of the array. Okay. Now we are checking whether the particular value, it is nothing but you can write it at I equals to 0, I less than nums dot length I plus plus. The same thing I have written like this for num of nums. Now we are checking whether this array of I, nothing but nums, is equals to candidate 1, then update the counter. If it is with candidate 2, then update the counter. What if the count is 0? That means nothing. That means the frequency is 0. That means our candidate 1 will be the value present over there. We are going to update the counter as 1. Similarly, for count of 2, we are going to do it for the second counter. And lastly, what we are going to do, we are going to decrease the counters. Okay. Now this was the initial phase of the Boyer-Morse algorithm. Candidate selection. What I can write it as candidate selection, which is my most potential candidate. That is how it can be selected. Now I even have to validate the candidate again. So we have to use another for loop for validate. So candidate validate uses again two counts. This loop is run. It is checking for num1, or it is increase the count, or same thing which we have done in the first and two steps. Now you will ask me that why I am repeating this thing, because it's an additional security check, or you can say additional validity check. Okay, which checks whether any elements are left behind or not. After that, what we will be doing, we are checking that these received values, the count 1 and count 2, are greater than n by 3. Then in our result array list, what is our result array list? This is our result array list. We are going to add the first candidate value and the second candidate. Remember, we don't have to add the frequency. We have to only add the candidates. Lastly, we're going to return the result. So that was today's problem statement on majority voting algorithm. If you guys understood this problem statement, make sure you guys like, share, and subscribe to the channel, and drop a comment down in the comment box. Thank you so much.